Hello friends, welcome to massive open online course on data analytics. Now we are going to discuss on the part 2 of Unit 2 classification and clustering techniques. Decision tree is one of the easiest and popular supervised classification algorithms which is used to predict the class or value of the target variable by learning simple decision rules inferred from the prior data, which are called basically training data. Eventually, it is capable of providing production rules. Another advantage of using decision tree is that the ease and efficiency of their construction compared to that of other classifiers such as neural network. In decision tree, the task of predicting a class level of an object is started from the root attribute. Thereafter, the values of the root attributes are compared with the object's values. On the basis of the comparison, we follow the branch corresponding to that of value and jump to the next node. There are a few key terms which should be known to know decision tree, like root node, which is useful for representing the entire population or the data set, and this further gets divided into two or more homogeneous sets. Then splitting, it is a process of dividing a node into two or more subnodes. Decision mode, when a subnode splits into further subnodes, then it is called decision node. Next, leaf nodes, when they do not split, is called the leaf or terminal node. Pruning, when we remove the subnodes of a decision tree, this process is called pruning. Branch, a subsection of the entire tree is called branch or subtree. Then finally, parent and child node, a node which is divided into subnodes is called a parent node of the subnodes, whereas the subnodes are the child of the parent node. The algorithm let us describe by an example where a decision tree is used as a classifier for determining an appropriate action. Let us take this example where it is considered that a task, the task of targeting good candidates to be sent an invitation to apply for a credit card. Given certain informations about an individual, we need to determine whether or not he or she can be candidate. In this example, information about an individual is given as a vector of attributes that may include sex, age, status like student, employee or unemployed, then college grade point average, which is GPA, annual income, social security number, etc. The allowed section are viewed as classes which are in this case to offer or not to offer an invitation. Henceforth, the decision tree that performs this task is sketched in the following diagram. For the given class, like query class, where a name is Andrew, social security number is given, age 22 years, he is a male person, he is a student, annual income 2000, college GPA 3.39. Then how we can classify this case into a particular class by using decision tree, where you start with the root status and follow the branch labeled as student. Then at the test node, where age is greater than or equals to 21, we follow the true branch, and the test node GPA greater than 3.0, we again follow the true branch. This leads finally to a leaf labeled called invite. Hence, our decision class is the invitation class, indicating that this person is to be invited according to the decision tree. Next, very important classifier called k nearest neighbor classifier. The basic principle from this diagram can be easily understood. You can see the diagram where a set of training records are given, varieties of birds are given, and a query like a test record is another duck is given. Now, the rule if reflected is like this, in the bracket it is mentioned, if it walks like a duck and quacks like a duck, then it is probably a duck. So, you have understood that the test record, which is an unlabeled DAG, is to be classified based on the training records. So, training records, you have a different ducks, hens, like other birds altogether. So, this unknown test record, which will be classified in which kind of bird, that is the problem. So, now let us understand the KNN classifier from the analytical point of view. The data consists of training data and test data. The training set is a set of n number of feature vectors and the class levels, because it is a supervised classification. Then a learning algorithm is used to train a classifier using the training set. And finally, the test set is a set of feature vectors to which the classifier must assign the labels. Okay. That means prediction of the class based on the features. Now, from this diagram you can see there are two classes. One class contains minus symbols, another class contains plus symbols, and there is a one red dotted points. So, plus and minus symbols, they are training data sets which are labeled, and the red dotted unknown record is basically a testing data point. Now, can we label this testing record based on the training records? Therefore, what we do, by KNN we look for k number of points which are closest to the red point, and this test point is then classified according to the class to which the majority of the k nearest neighbors belong. So, in this case, in this diagram you can see there are 3 neighbors have been considered as the closest one to the test record, that is red dotted point, and we find all the 3 data points, training data points, they are plus class, they are from the class 1, that is plus. So, red unknown record can be classified in the class which have the symbols plus. In this way, k may be 1, k may be 2, k may be 3. So, that is one nearest neighborhood classifier, where with respect to there is a one label called x in the diagram you can see, and only one point is the closest most one, okay, and that is minus. So, the unknown pattern, that is x, is being classified in the class which has the minus symbol. So, we are basically interested to find out the smallest distance between k to x. We use different distance functions, both like Euclidean distance, Manhattan distance, Minkowski's distance, but amongst all Euclidean distance is found to be the more applicable. Now, we are moving to the second paradigm of the classification techniques, which are called unsupervised classification techniques or clustering techniques. Amongst several clustering techniques, hierarchical clustering is very popular because it is easy to understand, easy to apply, where the data are obviously unlabeled and fully driven by the features. In this case, the clusters are obtained based on similarity and dissimilarity measures amongst the patterns following hierarchical structure. Here basically we transform the pattern matrix into a proximity matrix. So, pattern matrix means we have a number of samples which are being characterized by p number of features, and we are going to compute the distance between every two pair of the objects which are categorized by the feature. So, here are n number of objects. So, we will get NC2 pairs for which we are going to compute the distance values, and this distance value, which is proximity value, is usually computed by the Euclidean distance, on the basis of which the clusters in the data are formed. There are mainly two types of hierarchical clustering called agglomerative clustering and divisible clustering. Now, let us understand the algorithm of the agglomerative clustering, where we start with the n data points and compute the proximity values and generate the proximity matrix. Then find the smallest proximity value and merge the corresponding clusters to a cluster having minimum 2 data points. Now, compute the proximity matrix for all the initial and newly formed clusters in step 3 and repeat the steps 3 and 4 iteratively until we all converge, the all data points converge to a single cluster. Next, divisible clustering algorithm, it is just opposite principle to the agglomerative clustering, where we start with a single cluster having all the n data points, again compute the proximity values and proximity matrix, and then find the largest proximity value and split the corresponding clusters to generate the subclusters, and hence we compute the proximity matrix of all initial and newly formed clusters in step 3 and repeat these steps 3 and 4 iteratively until when n data points are separated as n clusters. Following both the algorithms, we are able to generate a diagram called dendrogram, where where it is drawn as per the computed proximity values and finally produce a binary tree. The final cluster is the root and each data item is called a leaf. Now, another algorithm which is very popular called k-means clustering, introduced by McQueen in 1967, and it is basically one of the widely useful unsupervised classification techniques which assumes the fixed number of clusters. The basic principle is to minimize the total mean square error between the cluster centroids and the data points. So, in this objective function you can find out the distance between the jth pattern to the ith class and how and compute their square Euclidean distance value to find out the total across all the classes, what is the total amount of distance, and that needs to be minimized. So, it is an unconstrained optimization technique. So, to discuss the algorithm, we initialize the value of the k, that is k number of seed points have to be assigned first, and every data point needs to be assigned to that particular seed point and make a cluster, and finally compute the centroid for each classes for which the distance is minimum, and stop the algorithm when there is no change in the centroid values. There is no data is left unassigned in one of the classes. With this, I thank you very much to this session, and to know more in detail, you follow the e-content. Till the time, goodbye.